How do CNNs work like the human visual cortex? Imagine your brain recognizing a face or a cat in a photo. It does this by processing visual information in a layered way. That's similar to how convolutional neural networks, or CNNs, work. They process images through multiple steps, each building on the last. This process mimics how the human visual cortex, the part of your brain responsible for seeing, works. In your brain, the primary visual cortex starts by detecting simple things like edges, lines, and colors. These are the building blocks of what you see. CNNs do the same thing in their early layers. They use filters to scan the image and find basic patterns such as edges and textures. Think of these filters as tiny windows that look for specific features. As the information moves deeper into the CNN, the layers combine these simple features into more complex shapes. For example, edges and textures might come together to form parts of an object, like a nose or an eye. This is similar to how higher visual areas in the brain recognize whole objects by putting together basic features. Research shows that the lower layers of CNNs match activity in the early parts of the human visual cortex. They pick up on simple visual cues. The higher layers match activity in brain regions responsible for recognizing complex objects and categories. So, CNNs are good at telling apart cats from dogs, cars from bicycles, because they mimic this layered process. CNNs also process images in a feed-forward way, meaning information flows from the simple layers to the complex layers quickly. This is like how your brain rapidly recognizes what you see without needing to go back and forth. The brain has extra pathways that CNNs don't fully imitate, but the main idea is similar. This similarity helps AI systems like DALL-E and Midjourney generate images based on learned visual features. They can understand and recreate images in ways that resemble human perception. But it's important to remember that CNNs don't fully replicate the brain's higher-level visual processing, especially for very complex or artificial images. Understanding how CNNs work like the human visual cortex helps us see their strengths and limits. It explains why they excel at tasks like image classification and recognition. It also reminds us that while they are inspired by human vision, they are still simplified models. They process visual data in a layered, hierarchical way that makes AI systems smarter at understanding images.